This video is about using the properties of angle pairs to prove that lines are parallel. So yesterday we learned that corresponding angles, alternate interior angles, and alternate exterior angles are congruent. We also learned that same side interior angles and same side exterior angles are supplementary when we have parallel lines. Today, we're going to use the reverse. So if we know a given set of angles are congruent or a given set of angles are supplementary, then the lines are parallel based on their angle relationship. So let's look at that in a figure. Determine which lines, if any, are parallel, justify your answer. So in number one, they're telling us that angle 2 and angle 10 are congruent. Well, angle 2 and angle 10, because they're in the same position in their group of 4, are corresponding angles. And since they're congruent, that means the lines that are not the transversal would be parallel. So if A is the line they're touching, that's our transversal, which means that C and D are parallel because corresponding angles congruent. Number two, angle 4 and angle 5. So angle 4 and angle 5 are on the outside of their lines, and they're on alternating sides of the transversal. So because we have alternating exterior angles that are congruent, we would say that A is parallel to B by alternate exterior angles that are congruent. In number 3, we have angle 13 is equal to angle 8. Is congruent to angle 8. Now, both of these angles don't have any shared sides because 13 is touching D and A, 8 is formed by B and C. Since they don't have a transversal, there is no relationship, so we can't show that any of our angles or sides are going to be parallel because there's no angle relationships. In number 4, we have the measure of angle 10 plus the measure of angle 11 equals 180. So remember, if it equals 180, that they are supplementary. And because they are same side interior angles, that's the relationship with those angles. So we would say that if our transversal is D for the same side they're on, our lines then are going to be A and B. So A is parallel to B because of same side interior angles congruent. So now let's use this idea to solve for x. So it's the same idea as we did the day before, it's just worded differently. So find x so that A is parallel to B. So we need to know the value of x that makes these lines parallel. So looking at our angles, these are alternate interior angles because they're between A and B and they're on opposite sides of the transversal, which means they have to be congruent. So we're going to set them equal and solve for x. So first I'm going to subtract 3x from both sides. And then I'm going to add 11 to both sides, so 32 equals 4x. Divide, and we get x equals 8. In number 6, when I look at my transversal, my angles are on the same side of the transversal, and they're outside of their respective lines, which means that these are same side exterior angles, which are supplementary. So we're going to add the angles together and set them equal to 180. So when I combine like terms, I get 21x plus 33 equals 180. Subtract 33 from both sides, so 21x equals 147. Divide by 21, and we get x is 7. Number 7, looking at these angles, these are also alternate interior angles, and alternate interior angles are congruent. So x squared minus 3x is equal to negative x plus 14. Because there's an x squared in this term, in this problem, we need to move everything to that side so we can factor. So I'm going to add 8x and subtract 14. So we get x squared plus 5x minus 14 equals 0. And then I'm going to solve for x. So I need to figure out what multiplies to negative 14 and adds to 5. So I have x plus 7 and x minus 2. And when I switch my signs, I get x is negative 7 or x is positive 2. When I go back and look, though, at my angles, If I was put -2 into this angle, I would get it, or if I was put 2 into this angle, I would get a negative number, which means 2 can't be a solution. If I put -7 into both angles, I get a positive, which means x is only equal to -7. Number 8, given that A is parallel to B, solve for x, is C parallel to D? So right now, we know that line A and line B are parallel. C and D are just seen as transversals. So in order to solve for x, I need to use an angle relationship on the same transversal. So looking at the blue, I have alternate interior angles that I can use to solve for x. So 7x minus 44 is equal to 3x plus 28. So I'm going to subtract 3x from both sides, and then I'm going to add 44 to both sides. So I get 4x is equal to 72, and then divide by 4, so x is 18. So now, to prove if C is parallel to D, I'm going to put x into this angle down here so I can find that angle. So 3 times 18 plus 28 is 82 degrees. Now, if C and D were parallel, these would have a relationship because they're corresponding angles. So I'm also going to put x into the other angle, x squared minus 180. And I get that the angle is 144 degrees. So because the angles are not congruent, C and D are not parallel. So I would say C is not parallel to D because corresponding angles are not congruent.